Hello everyone, we are from Group Quantifiers. Our topic is quantifiers for MAT222.
Today's cases is about quantifier, the logic behind words like someone and everyone. Quantifier are not only used in mathematics, but it also can be used outside mathematics too. For example, in computer science, first of all, check if all the users are logged in. This is a universal quantifier because of the word all refer to every user. It means every user must satisfy the condition. After that, find some user with a problem. This is an existential quantifier because of the word some means that at least one user exists with a problem.
Okay students, today we're going to learn about quantifiers. There is two types for quantifiers, which is universal, which is this symbol. It's like an upside down A, and then there is existential, which is the symbol is backward E. So the words for universal is all, or many, or every. And for this essential is some, or there exists. Meaning that for universal is for the statement to be true, every single object for the statement must be true. For existential, for the statement to be true, only one has to be true. In logic, quantifiers helps us to tell how many objects satisfy a statement. There is two types for quantifiers, which is universal. The symbol is an upside down A, and existential, the symbol is a backward E. For universal, the word that we use is for all and every. For existential, the words are usually some and there exists.
Teacher, can you give me an example for both universal and existential for us to understand more?
That's a good question. For universal, the example is, let's say, every student has a student ID. And for existential, let's say some student didn't submit the homework.
Alia, do you understand what teacher just said yesterday?
Yes, what?
Can you explain it to me? I don't quite understand it.
Sure, come on, let me show you.
Okay, does everyone bring their book today?
I bring it.
Me too.
Oh my god, I don't.
Example 1. Universal quantifier, or we can say it as upside down A. For this example, we can define domain as all students in the class and B of X as X brought their book. So the logical statement states that for all X, B of X, which means every student brought their book. When we check for each student, student C brought the book, so the statement becomes true. Same goes with student A brought the book, so the statement also becomes true. But student B did not brought the book, make the statement become false. For a universal statement for all x b of x to be true, every single value must be true. Since b of b is false, the statement becomes false. Therefore, for all x, p of x is false because one counterexample b is enough to make it false.
Aya, look mate, I was thinking of doing the group project. Do you guys have class after this?
No, I'm free.
But I'm not. Can we do it tomorrow? Sure.
I will explain the existential quantifier represented by the symbol backward E, which means there exists at least one. For this example, we define the domain as the members of the group, and let Cx mean X has class after this. So, the logical statement is backward EX Cx, which means there exists at least one person who has class after this. When we check each student, student A does not have class, so their statement is false. However, student B have class, so their statement is true. For an existential quantifier, we only need one true case for the entire statement to be true. Since student B satisfies the condition, we conclude that backward EX CX is true. This is an example of an existential quantifier because it shows that at least one person in the group has class after this.
Wow, what a handsome young man. I bet he's someone whom everyone admires.
Not really, I don't admire him.
What? Seriously? There's no way you don't admire him at least a little?
Why not? I don't even like his blonde hair. I can tell he's handsome, but it doesn't mean I like admire him.
Come on, everyone must admire him. He's just for God's sake.
Ew.
Hold on. You guys are saying two different things.
What do you mean?
I mean, you're saying that there's someone whom everyone admires.
Which isn't true because I don't even admire him.
Exactly. For your statement to be true, every single person will have to admire the same person, the blonde guy.
And since she doesn't admire him, my statement is false?
Correct.
What I'm saying is different. Everyone usually have someone they admire, but it doesn't mean have to be the same person.
That's the key point. For example, you admire the blonde guy, you admire your teacher, while I admire my own sister. Everyone has someone they admire.
So that statement is true?
Yes, because each person can choose a different person to admire.
Oh, so everyone has someone they admire doesn't mean they all admire the same.
Exactly. That's why these two statements are different.
Even though they sound the same.
In logic, the order matters. Everyone has someone they admire, which means for every person, there exists someone they admire. There is someone whom everyone admires, which means exists one person admired by everyone.
Ah, I get it now. Just because everyone admires someone doesn't mean there's one person admired by everyone.
That's precisely the difference between the two statements.
I see, I get it now. Thank you.
Bye.
Example 3. Nested quantifiers. In logical form, let's say that domain is equals to student A, student B, and student C. And AXY is equals to X and minus Y. For statement A, it says that there is someone whom everyone admires. So this is the symbolic expression. In these tables, it shows that student A admires blonde boy, student B admires her own sister, and student C admires her teacher. So this is the symbolic expression. As we can see that there is no one person whom every student admires. So therefore, the true value of this statement is false. Meanwhile, the statement B shows that everyone has someone they admire. As we can see back on the table, it shows that every student has at least one person they admires. Therefore, the true value of this statement is true.
Okay, students, can anyone tell me what is the symbol for everyone and a symbol for someone? Okay, student A.
For everyone, we're gonna use upside down A. For someone, we're gonna use backwards E.
Yes, that's correct. Can anyone explain to me what is the quantifier for the first statement? Okay, student B.
The first one is universal quantifier because requires everyone.
Good job. What about statement 2? Okay, student C.
For the second statement, it is existential quantifiers because it requires at least one person.
Quantifiers are operators that specify the scope of elements in a given domain that satisfy the specific condition. They turn open statement into complete proposition, which is strictly true or false. Today we solved the mystery of quantifiers.
Universal quantifier means every object must satisfy the condition.
Existential quantifier means at least one is needed.
And nested quantifiers is a special case where both statements are true depending on their order.
And lastly, quantifier can be expressed by idea more effectively.
Thank you all for watching. Bye!